Let's solve for SEC inverse of -2 and understand what this means geometrically. First, let's recall what SEC inverse means. The secant inverse function finds an angle theta such that secant of that angle equals our input. In this case, we're looking for an angle theta where SEC theta equals -2. Let's visualize this on the unit circle. Remember, secant is the ratio of the hypotenuse to the adjacent side in a right triangle, or in terms of x and r. Secant equals are divided by x, where r is the distance from the origin to a point on the secant line. Since we want secant to equal -2, the ratio of r to x must be -2. This means we need to be in a quadrant where x is negative and r is positive, since r is always positive as it represents distance. For secant to equal -2, we need a point where the x-coordinate is -1/2, since 1 divided by -1/2 equals -2. Let's draw this point and connect it to the origin. There are two angles that satisfy our equation, one in the second quadrant and one in the third quadrant. However, the domain of SEC inverse is restricted to I0 pi/2 union pi/2 pi, which means we take the angle in the second quadrant. Therefore, SEC inverse of -2 equals approximately 2.186 radians, or 125.3 degrees. To verify this answer, we can check that the secant of this angle indeed equals -2. And when we plug 2.186 into our calculator, we get secant of 2.186 approximately equals -2, confirming our answer.